All right, so this is an exponential, and it could be e to the x, or it could be like 2 to the x. It's hard to know exactly how steep that is, but if you have 2 to the x, or 3 to the x, or e to the x, they're all pretty close to each other, because e is really about 2.718, so it's right between 2 to the x and 3 to the x. All right, what do they all go through? That spot right there is what? 0, 1. Yes. All right, so there is a sketch of it. That's all we have to do for that one, except for give the domain and range and write an equation for it. Okay, domain and range for e to the x is, well, domain goes this way and this way. Is there any limits to it? Does it stop ever? Okay, guys, please focus. You need to put those little blue things away that are distracting you. Put them in your backpack. All right. Domain is, yeah, there's no limit to it. It goes forever both directions, so negative infinity to positive infinity. And then the range. How low does this thing go? It does have a limit. There is an asymptote line down there at 0. So it goes from 0 to, what's the highest it would go? Infinity, good. And then I should put parentheses around all of these. And then the last thing is asymptotes. What? It will never touch 0, and therefore, parentheses. Guys? All right, on to the last one is asymptotes. The asymptotes for this are, well, there's only one dotted line here, and that's at 0, but what is it? Y equals 0 or x equals 0? And it seems like it's the x-axis, which seems like it should be an x thing, but it's y equals 0. All right, so there's our little type of problem, 1 through 4. I've given you one of them. You can try the others. Moving on to number 5. Describe the end behavior using limits. My first thought on number 5 there is that it is not an exponential growth, it's exponential decay, so generally it looks like this. And now we have to put the asymptote, sorry, don't really have to write the asymptotes, we have to write as a limit. Limit of the function as x approaches whatever. Well, it doesn't say you're supposed to just do the right end or the left end, so I really should do both. The left side is way over here. And if I go way over there, the limit of that as x approaches negative infinity would be infinity. And if I go way over this way, the limit of the function as x approaches infinity would be how the, because this is the x, and we want the y here. And what's the y? When I get there, it would be about 0. And again, it approaches 0. It's not actually 0. Just to clarify on the logistic ones like number 7, the quick sketch on number 7, you don't have to sketch them, but it really does make it easier. If I have a 25 about here, do you remember how these things look? I go like this. Now, don't be concerned because that has an e to the negative x in the problem. What that really means is 1 over e to the x, which really means 1 over 2.718. So it's just a normal one. In the problem doesn't mean you have to flip anything. Okay, we talked about that before, and I just don't want you to think that whenever you see a negative in the exponents, you're supposed to necessarily flip it. If it's a logistic like this, it's supposed to have a limit on the top, and it's supposed to have 1 plus a b to the x, where b is like, so if sometimes they put like an e to the negative x here, it's still a fraction. It's just a different way of writing a fraction. Okay, so what's the point? Okay, I missed. Okay, what they're not asking me to give an equation for this. All they want is the end behavior. So do I know how the thing ends now? Yeah, I know how the thing ends. It ends at the highest point it goes to. What's the highest point it goes to? 25. Yes? What point? Right here? Okay. That is known as the y-intercept, right? The y-intercept is where what? So then I can take this equation that I have right here, put in x is 0, and I can figure it out. All right. Okay, but on this one, all I need is the limits. So I'd say lim of the function as x approaches whatever. And if it's the way right side, like way over there, I'm doing positive infinity, and that would be 25, because that's the highest it goes to. And if I was doing the left side, it'd be negative infinity, and when it gets there, it would be way over here, it'd be 0. All right, moving on. The other page, the next page, number 8. And for basically the whole rest of this worksheet, you're writing equations. It's a whole bunch of writing equations. So of course, you'd expect on the test you have a lot of situations where you got to write the equation for it. Let's do number 8. There's 2,400 moose in Minnesota at the beginning of 2012. The population declined by 35% and will continue to do so. That sounds like exponential decay. Generally, it looks kind of like this for decay. All right, so what do I want? I want an equation. Y equals starting value. And then there's always a b to the x here. And do I know the b? Nope. But can I figure it out? Yep. They tell me 35%, so I cannot put this, though. I got to say it's 35% decay. I go 1 minus the 35. All right. And that is it. It does not use the number 2012. Okay, I guess that's not necessary to this problem. It's just telling you the start value and happened to be in that year. Okay, so no, that's if it's one of those problems like doubling or whatever. Let's go to one of those. Flip to number 16. Nope, I'm wrong. 17. I'm still wrong. That's not one that you need to do. Show the. There's one that you, like somebody asked about. What are the kind where you have to say in years or whatever? 24. 24 is definitely one like that. Flubber is an interesting material that doubles its weight every 7 days. It starts out at 55 grams. So I know I go y equals 55. Start out at. And then how do I do doubles? Yep. I could have said 1 plus 100%. 1 plus 1 is 2. And then it's to the x, and then the only other thing I need is divided by 7, and then I got to say in days. Make sense? All right. Let's do a logistic. We haven't done many logistics so far throughout this worksheet. There's a bunch of them. Let's look at. Here you go, sir. Let's look at number. I think there are 2 on the bottom of that stack. They're blank. All right. Let's do number 20. You're correct, and that's okay. Another logistic model starts at 10, has a limit to growth of 50, and passes through 2, 18. All right. I'm going to make a little sketch. Don't have to, but I kind of like to. It's logistic, so it goes like this. Limit to growth of 50, like that. It's got a passes through 2, 18. 2, 18. So whatever that, I'll call it 2, 18. Somewhere in that neighborhood. And then, wait a minute, starts at 10. Okay, so there's a 10 right here. And if it's a 10 right there, it's really 0, 10. Notice it didn't say that, but you have to know that. If it says it's a start value, you should know it means 0, 10. Now, these are the biggest, nastiest kind. You go y equals 50 over, and then you got this 1 plus a b to the x thing going on. And the a part, we will figure out first by sticking in 0, 10. You cannot just put a 10 in here. That will not work. X is 0, y is 10. 10 equals 50 over 1 plus a. And then I'd multiply both sides by 1 plus a in a parentheses. And then I'm going to divide by 10 on both sides. 10, not subtract, divide by, so it's 5. And then I'm going to subtract 1, a equals 4. All right. So we're at y equals 50 over 1 plus 4, b to the x. And I'll let you figure out this last part is definitely the hard part. X is 2, y is 18. And you got to multiply by this on both sides. And then you'll have to divide by 18, then you have to subtract 1, then you have to divide by 4, and then you have to put it to this 1/2 power, and it'll be ugly. That's the hard part. But at least I think we've done enough of these that you should be good to go. Just be careful. All right, a bunch of practice problems, a bunch of time. Get to work. If you need help, ask. Want extra help before you take the test on Monday, feel free to come in the morning. But don't come in the morning with all of these blank and say, help me, we won't have time. If you come having tried all of them and you're stuck on a couple, that'll work. And there should be answers posted for this too. What time is lunch? Lunch is